Hello everyone, my name is that tech guy. Now in this Solidity tutorial, we'll be creating a random number generator, using the KSAC 256. So I'm trying to generate the random numbers based on specific range and non-specific range. So then of course the first thing to do is open a Remix IDE and create your Solidity file. So I will be creating my Solidity file here, naming it random. Then N is just a short name or for a short interpretation for number. .sl is my extension. Then of course I try to activate my file. So of course the first thing to do is to specify your license, SPDX license identifier. So I can either I'll just use MIT for this tutorial purposes. So the next thing, of course, for you to do is to create your Solidity version, specify your Solidity version rather, pragma Solidity. Sorry, pardon me. Solidity. Then I will try to use 8.8.19. Of course, there are several versions, but just using and versions greater than 0.8.19. So the next thing to do for me is to create my contract. So contract, I'm going to name it random number. My contract name, random number. So I will specify because I'm basing it on random, of course, random numbers, so it has to be a unit, which is an unsigned integer. Round nonce equals to 0. So I'm initiating my number. This is a state variable. This is initializing a state variable. So I'm initializing this state variable as 0 because I'm actually trying to get the random numbers. So based on these values, start generating the numbers from 0. So the next thing for do is to write a form. I'm going to write a function. A function to actually generate this number. A function to generate, pardon me. Okay, function to generate random number. Okay, within specific range. Now will be for this tutorial reasons, for this tutorial purpose, I will create two functions. The one that actually generate numbers based on specific range, and the one that also generate numbers based on non-specific range that's being given. So because I'm trying to create, of course, a function that creates that gets a random number. So this is entirely what I'll be doing here. Random generator I'm going to be using a KSAC function, KSAC 256. So like I said, I'm using a function to generate random numbers. So the first thing is, of course, using the keyword function. This is just the name of the function, random. I'm shortening. So I'm going to be accepting, of course, a value modulus. Now because I'm trying to get a number within specific range, hence using the name, the data type name of modulus. So and going further, you will understand what I'm trying to do. So external, then returns. I'm trying to, of course, you should return a value, returns the unit value. Then what I will do, I'll increase the nouns. Then of course the round nouns plus. Then because I am, of course, returning unit value, so I have to also return my KSAC. But before that, let me explain what I'm actually doing in this section, in this function to generate a number within specific range. So because this, of course, is a variable name of the function, I'm going to be accepting a unit value, and I'm giving that unit value a visible modifier of external. So what this we simply do to this aspect is that because I'm using our word external, it's actually this acting as a modifier that will restrict access to a function, or it's going to restrict access to a variable from outside this current contract I'm writing. So that is the function of this external. I'm using this now so that it won't be the other smart contract will easily access this function or this smart contract. So that's me giving me the external modifier. So this is, I'm using it to restrict access to a function or a variable from outside of the smart contract. So what the essence of this external is just to prevent function, like I said, prevent function or a smart contract, so that it won't be modified by another third party code. Let me just put it in that layman language. So what these nouns, what I'm actually using for these nouns N or NCE, what it simply means is a short term for a number used once. That's the meaning of these nouns. So random nouns, it means, of course, random number, but it's actually random number that is used once. It means I'm trying to generate number randomly from each transaction, so it should only be used once and should always be gotten once. This is why I'm doing it. So because I'm initializing it at 0, so I'm increasing that number. I'm adding the number 1 to it, which is hence me using a plus sign. So because I'm returning in my function, I'm returning a unit, so hence I'll bringing up this return unit. Now, like I said, I'm using ksac to generate my random numbers, which is why I said random generator using ksac. So I'll use the ksac, of course, 256. I will explain this aspect very soon. For ABI.encode packed, I'm going to be encoding this pack, then block.timestamp. Sorry about that. Block.timestamp. Then of course message.send, means the address of the person calling this smart contract. Then round now is what the variable that I've declared here. Then because I'm using modulus, I'm accepting a unit number, and like I said, I'm using the modulus name of the data type, or the variable name rather, so that you understand that okay, I'm dealing with modulus here. Then of course modulus. So this is the first function to generate number within some specific range. So let me explain what this simply means. Now, like I explained earlier, what external is, but now because I'm trying to use my ksac as a generating factor for getting my random numbers, so I'm going to be returning a uint, that is of course an unsigned integer. Then ksac, what this ksac refers to, like this ksac 256, is actually an hash algorithm. Now it is used to generate a we call 256-bit hash value from an input string. So any value I'm inputting within this ksac 256 is going to generate a 256-bit hash value. Now this hash algorithm can be used for, of course, many purposes. You can use it to verify integer data. This ksac 256 can be used to verify integrity of data, of course, and also to create unique identifiers. So the sole aim of me using this ksac 256 is I'm trying to create an hash, it is for hash algorithm, so I'm trying to use it to generate 256 hash value from any input string. But because I'm using the modulus, so modulus value or modulus calculation is going to generate that value within the specific range I'm giving. So which is hence I used the round nouns. Like I said, rounds is a number that is used once, starting from 0. So any value I'm inputting in this, because I'm saying this should accept a value, if I'm inputting so it means they generate that value within that particular range from 0 to the value I'm actually giving it to running. So let me run this, then let's see our output. So all right, it's giving me an error. That's okay. So what I have to do is it's saying the source file requires different compiler, so I have to go to the compiler, the version specification, and give it something higher than 0.8.19. Let me just go upward and use the latest local version. So I hold on for a while. Okay, it's still loading. Oh, see, all right, when you're actually doing your code, you have to make sure your spellings are correct. So I had to clear my C here again. Then of course, let me save again. Let's see if it's going to go through. Oh, all right, the compilation has been successful. I'm going to deploy my transaction. So if you look further, I've been able to deploy my smart contract. So because I'm trying to, of course, get the random numbers, so from the onset I've declared that my round nonce is equals to 0. So I said this function should accept a value of probably any numbers, any integer, non of course unsigned integer, which is non-negative number. So let me just input 5 as my random number. Then when I click on random number, so come into this terminal to check your output of the values. So you click on this side, so you scroll down. So now my decoded in between my decoded input, it shows that it's accepting 5 as my modulus. Then my decoded output shows that is outputting 2 as my value of random integer. So let me do this again. Let me say 7. Then of course go and check again. So it means I'm accepting a random number as a unit of some modulus 7. Then my decoded output as my output for the random number, it gives me 0. So let me use one more. Let me say 6. Then click on the random number. You scroll down, so it's giving me 4. So definitely this is actually working within the confined range I've given it. Then I say it should start from 0. Then any number that I'm giving it again, it means within that specific number from 0, this is what I'm giving it. I'm giving it 6. So I'm saying within the 0 to 6 generates a random number within that range. So that is why I'm using the modulus, hence me using this modulus sign. Hence me using this modulus sign here. So it means when I'm actually going to be returning my value, when I'll be returning my value, you should use this KSAC as the generating factor. Then you put in the modulus form of what I'm giving you. So going further, I'll explain the meaning of course, the KSAC. I've actually explained the meaning of KSAC. It's an hash algorithm I'm using to generate a 256-bit hash value. So now the function of the ABI.encode, what is this actually does here? Is a function that is actually used to encode data in a format that can be used by the Ethereum virtual machine. So this ABI.encode back acts as a function. Now acting as a function in the sense that it's used to encode the data. So this data I'm putting a block timestamp, the message, the sender, the round nonce. These are the data I'm feeding the ABI.encode part, the function. I'm feeding the function encode part these 3 parameters as a data. So it's going to change, encode that data into a format that can be used, by this function of the KSAC 256. Now this ABI.encode part takes list of input values and return a byte array that can be used to represent these values. Let me come again with that. This encode ABI.encode part, what it actually does, it takes list of input values, and these are the input values: block, timestamp, message or sender, and rounders, and it returns a byte array that can be used to actually represent the values. So these are the data, or these are the input values rather. So what the block.timestamp simply does is that it takes the timestamp of the current block on the Ethereum blockchain. It takes note of that timestamp. So where it applies to this case activity, that the current work or the current smart contract, it keeps track of that transaction on the blockchain. It keeps track of it because I'm trying to create a random numbers. Of course, it keeps track of that random number that has been generated of within a specified range. That's what the block timestamp is functional. And this is also an address. It's accepting an address of the smart contract. I mean, this is depending on the smart contract. And randomness, like I explained, because of the randomness value that I've given here, it is 0. So it definitely assigns it when I'm calling the function random. So an increment, it assigns it into the data of the ABI.encode part. Then in modulo sign, then of course perform arithmetic operation, the modulus based on what I'm giving it. So this is just an illustration of generating random number within specified range. So in order for me to generate random numbers that's not in a specific range. So what we have to do is just simple, to generate random number in non-specific. So I'm just going to create, of course, random 2. Now I won't accept any value, because I'm trying to generate a number that is not within a specific range. I'm not giving a range, so I'm not going to accept any value, from the user. I'm just going to generate it based on give me any values that then of course external returns. I'm going to return a unit, which is likewise some. I'm going to increase the nonce, which is what I did earlier on. So the steps are almost similarly, just when I'm trying to print or return using a return statement, because I'm actually returning my unit. I'm going to return. I'm not going to put it in the form of my calculation pattern. So case arc, of course, case arc 256 ABI.encode. Then of course I'm going to be accepting block the timestamp, but I'm accepting message or sender. Then one more thing is to random nonce. So this is the second function of you generating random number in a non-specific range. So I've been able to successfully deploy this smart contract. Then I'll go further to I compiled it successfully. Then I will deploy this transaction. All right, so this is the first one. This is to generate random number within some specific range. So like I said, I've declared 0 here, so let's say 0 to 6, and just come to the terminal to check it out. Then from a decoded input, this is what you input 6, then decoded out with, it gives me 5. That means from 0 to range of 0 to 6, generate a random number, it gives me 5. Then using the second function to generate a number in a non-specific range. So immediately I click on random 2, then of course I go to my decoded output. So it's going to generate a list, or a bytes rather. Like I said, what this function as this case activity ABI.encode pack, is going to generate that input of arrays of numbers in bytes actually, which is why, because I'm using a specific range here, so it's going to be giving me that privilege of giving me an exact value, compared to this that is generating number in a non-specific range, which will give me a lot of values that I don't necessarily need. But basically this is just an illustration of generating random numbers using case arc 256. Thank you for watching. So kindly like and subscribe and share.